This is the second part of a Level 2 Functional Skills Maths paper from NCFE. In this part you can use a calculator. Activity 2, Films. Liam downloads films from the internet. The table shows the number of films he downloaded last month. He chooses one of these films at random. What is the probability that the film he chooses is an action film that is at least 1 hour long? So we're looking for action films that are at least 1 hour long. At least means that that's the minimum, but it can be longer. So exactly 1 hour long and more than 1 hour long are the two that we're looking at, and specifically action films. So looking at action, we've got 2 here and 1, so that is 3 out of the total, which is 28. So 3 28ths. Liam thinks he might watch either Rainbow Prism or The Infinity Zone. He looks at the scores given by different newspapers. The scores are out of 100. Which of the two films would you suggest Liam watches next? Use 2 appropriate statistical measures to explain your answer. I'm going to look at the mean and the range. So it gives us an average score as well as how much variation there is in terms of the scores. So what I'm going to do, I'm going to add all of these together using a calculator, which gives us 534. And I'm going to divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9. Which gives us 59.33. So 3 is recurring. And I'll repeat the process, adding the totals here for the infinity zone. And that is 514. I'll divide it by 1, 2, 3, 4, 5, 6, 7, 8. And that gives us 64.25. So these are the means. I'll now look at range. So for the first one, what's the highest value? That is 83, and the lowest is 38. So 83 take away 38. So that gives us 45. Now looking at the infinity zone, the highest score there is 79. The lowest is 40. So 79 take away 40 gives us 39. Now, in terms of making a decision, we're looking for the highest mean and the lowest range, because highest mean means on average having a higher score, and the range means if it's lower, it means less variation, which is a good thing. So looking at the means, this is higher, and looking at the range, this is lower. So basically, we are going to suggest the infinity zone. Because it has higher scores on average, and less variation. Screen images are made up of units of light called pixels. Pixels per square inch is a measure of image quality. The higher the pixels per square inch, the better the image quality. And that's the formula how you work it out. So where n is the number of pixels and a is the area of the screen in square inches. Liam's old screen has a PPI squared value of 9,800. He wants to buy a new screen with a better image quality. Liam sees a rectangular screen that has a width of 101.6 centimeters, width to height ratio of 16:9, and 8.28 million pixels. He works out that this will have a better image quality than his old screen. Is Liam correct? Show your working. So to work the PPI squared value, as I'm calling it, and compare it to this one, what we're going to have to work out is n, the number of pixels, which we've got, and then the area of the screen. So number of pixels is 8.28 million pixels, and we can divide that by the area. But what is the area equal to? Right, and we know that area in this case would be worked out by multiplying width by height. We're given the width, but we're not given the height. We need to work out the height using the ratio. So if the ratio is 16:9, 16 being width and 9 being height. The width, we've got it here as 101.6. So that is in centimeters though, and we're looking at the area in square inches. So I'll first convert this into inches before I do anything else. However, if you want, you can just try and work out the height in centimeters and then convert both of them into inches before you do the area. So 1 inch is equal to 2.54 centimeters. What about 101.6 centimeters? How many inches is that equal to? So we'll do 101.6 divided by 2.54 gives us 40. So 2.54 times 40 gives us 101.6. So we'll do the same on this side. So 1 multiplied by 40 gives us 40. So the width is equal to 40 inches. And now we can work out the height. So if we do 40 divided by 16, it gives us 2.5. So 16 times 2.5 gives us 40. We'll do the same on the other side. So 9 times 2.5. And that gives us 22.5. So we've got both the width and the height. Now we can work out the area. So I'll put here 40 times 22.5 because that's what the area is equal to. So 8.28 million. So that's higher than 8 million. When we write 8 million, we know there is 8 and then 6 digits after that. So we've got 2 coming after the 8 and then the other 8. The rest of them we just fill with zeros, and that's divided by 40 times 22.5, which gives us 900. So doing this in the calculator gives us 9,200. How does this compare with the 9,800? This is lower. So is Liam correct? No, he's not. Liam searches online for a choice of broadband services. He finds this graph. Cost of broadband services, advertised broadband speed. Broadband speed is measured in megabits per second. The lettered crosses in the graph represent the different services. What is the modal speed of these broadband services? So modal, the most common, and if we look at them, we've got 4 of them here, whereas there are 3 here, 1, 1, 3, and 1. So this is basically between 30 and 40, which means 35. Using the graph from 2D, what percentage of these broadband services cost over £25 per month? Give your answer to 2 decimal places. So cost per month is here. We're looking at over 25. So this is the cutoff point. So it does not include I. So anything above that. So it would have G, L, K, J, M, and N. So that is 1, 2, 3, 4, 5, 6 of them. And that is 6 out of 7, 8, 9, 10, 11, 12, 13, 14. So 6 out of 14. So if we do this in the calculator, 6 divided by 14 gives us 0.428571 and so on. As a percentage, we move the decimal point 2 points to the right, so we then get 42.8571, and we've got to give our answer to 2 decimal places. So 2 digits after the decimal point. Looking at the 7 means we round the 5 up to make it a 6. So we get 42.86. This is the graph from 2D. We've got cost per month and advertised broadband speed. The actual speed of a broadband service depends on how far the customer's house is from the nearest connection box. Liam's house is 350 meters from the connection box. Liam wants to be able to download a 7,000 megabit film in less than 2 minutes. What's the cheapest broadband service he can choose? So 7,000 megabits in less than 2 minutes. So that is 3,500 megabits in less than 1 minute. And the house is 350 meters away from it. So in terms of the distance, it'd have to be this one here, which shows 85% of the advertised speed, which means that in reality there'll be 15% less than advertised. So speed is given in megabits per second. So let's work it out. So this is 7,000 megabits in 2 minutes. That is 3,500 megabits in 1 minute. There are 60 seconds in 1 minute, so we're going to do 3,500 divided by 60, which gives us 58.33 to 2 decimal places rounded. So this is 58.33 megabits per second required. However, as speeds are overinflated when advertised, this means that this is only 85% of the advertised speed. So if we show here the 100%, the advertised speed, what we've got is only 85%, and that is equal to, no, it shouldn't be money, it's speed. So 58.33 megabits per second. So we'll go 58.33 divided by 85, so we can get 1%. And this is about 0.68623. And we'll now multiply by 100 to get the 100% speed, the advertised speed, in other words. So 0.68623 times 100 gives us 68.623. So about 69. So looking at the graph, 69 would be roughly here. So J, K, L, M, and N, do we have that speed or higher? And out of them, the cheapest is J. So J will be the answer. Activity 3, building a pond. Arvia is involved in a community project group. The group are planning to build a pond in the garden of the local hospital. The pond has a path around it. On a scale plan, the width of the path is 6.7 centimeters. The scale used on the plan is 1 to 25. Calculate the actual width of the path. So the scale is 1 to 25, where 1 is for the plan and 25 is in reality or on the ground. Now, the width of the path on the plan is 6.7. So what will it be in reality? To get from 1 to 6.7, we've multiplied by 6.7. So we'll do the same on the other side, which then gives us 167.5 centimeters. So 167.5 centimeters is the final answer. The pond will be a cuboid. It will be lined with a sheet of plastic pond liner. The pond liner covers the bottom and sides of the pond. The pond liner needs to be cut to this shape to exactly fit in the pond without any overlaps. The dimensions of the pond liner are shown in this diagram. We've got sheets of pond liner are available in these sizes. Aria needs to buy the cheapest pond liner that is big enough to fit the pond. Which pond liner should she buy? Show your working. So looking at the length, so we have 7.65, but we also need to add 0.72 meters on this side and the 0.72 meters on this other side, which gives us 9.09 meters. Looking at the width, we've got 4.38, but we've got to add this length here, which is 0.72, and we've got to do the same on the other side. So adding them gives us 5.82 meters. So length being 9.09. So the cheapest would be here at 9.1, but we've got to check the width as well. It has to be 5.82 or something slightly higher than that. So this is just about it. So £130, option C. The group asked Aria to buy chemical treatment for the pond water to make it suitable for fish. One bottle contains enough chemical to treat 1,300 gallons of water. 1 cubic meter is equal to 220 gallons. Aria adds water to the pond until it is 92% full. How many bottles of chemical treatment will she need? Show your working. So, first of all, let's work out how much water she's going to put in the pond. So we'll need to look at the previous information. So we know that the length of the pond is 7.65, the width is 4.38, and the depth is 0.72. So we'll need to multiply these numbers to get the volume. So 4.38 times 7.65 times 0.72, which gives us 24.12504. And that would be cubic meters, because we used meters. Now we're looking at 92% of that. So 92 out of 100 times 24.12504 gives us 22.1950,368. Again, this is cubic meters. So now we can convert this into gallons. So 1 cubic meter is equal to 220 gallons. What about 22.195? Just going to round it to 3 decimal places. Cubic meters. So to get from 1 to 22.195, we multiply it by 22.195. So we'll do the same on the other side. So 220 times 22.195 gives us 4,882.9 gallons. One bottle can treat 1,300 gallons. So we'll divide this by 1,300 to work out how many bottles. So we get 3.756 and so on. Now, of course, we're going to have to round up because we can't buy less. If we go for 3 bottles, that's going to be less than all we need. So 4 bottles is the answer. Aria needs to work out how many fish can be put in the pond. She wants to have both koi fish and goldfish. The number of fish is based on the surface area of the water in the pond. Koi fish need 1.2 square meters each. Goldfish need 0.6 square meters each. Aria wants to have a mixture of koi fish and goldfish in the ratio of 1 to 4. What's the maximum number of koi fish and goldfish that Aria can put in the pond if she keeps the ratio of 1 to 4? The surface area of the water in the pond will be equal to the area of the base of it. And looking at the previous question we had, the dimensions of that are 4.38 by 7.65. So we'll multiply them. And that gives us 33.507 square meters. Looking at the ratio of 1 to 4, so 1 is for koi fish and 4 is for goldfish. If having 1 koi fish and 4 goldfish, that would be 1.2 square meters, and 4 lots of 0.6, which is 2.4 square meters. That is going to be 3.6 square meters. So how many 3.6s fit into 33.507? 33.507 divided by 3.6 equals 9.3075. So this shows we're going to need 9 lots of this. So that would be 9 koi fish and 9 times 4 goldfish. So 36 goldfish. The group needs to build a ramp between the hospital door and the gardens. The angle of the slope of the ramp must not be more than 5 degrees. This is a diagram of the ramp. Calculate the angle of the slope. So we're looking at this angle here, which is part of a triangle. And we know this is 90 degrees. So this one is 86. So 90 add 86 gives us 176. There are 180 degrees in a triangle, so taking away 176 leaves us with 4 degrees. So this is equal to 4 degrees. The diagram shows the measurements of the ramp. Draw the plan view of the ramp as seen from above. So from above we can see a rectangle with dimensions of 0.8 by 12.88. So this side is equal to 0.8 meters, or this one, either way. This one is 12.88 meters. The group need to order enough concrete to make the ramp. The formula to find the volume of a triangular prism is L times H times W divided by 2, where L is length, H is the vertical height, W is the width. Calculate the volume of concrete that is needed to build the ramp. So we'll need the dimensions. So 0.8 times 0.9 times 12.88 and then divided by 2. Which gives us 4.6368, and we can write this as it is or round it to maybe 2 decimal places, so 4.64 I would write. Activity 4, saving energy costs. Ellie needs to complete a project on energy costs for his college course. Ellie's family currently use X-Power for gas and electricity. They pay monthly by direct debit. X-Power uses the median monthly cost for January to June to set the amount of their monthly direct debit payments for July to December. The graphs show their energy costs for last year. We've got the graphs. Ellie works out that they have paid too much between July and December. Calculate the percentage by which they have overpaid. So they use the median of the energy costs between January and June to determine the cost for energy between July and December. So let's work out the median. The median of the costs between January and June would sit between March and April because the prices or the cost has gone down. So crossing them out both sides leaves us with these two in the middle. So for March, this is 160, and for April, this is 145. So adding them two together and dividing them by 2 gives us 152.5. So that's the median. If I multiply it by 6 for the next 6 months, that gives £915 in total. So let's see whether this is correct. So adding the different amounts, we get here 65 and 65. So I'm going to write them here, 65, 65, then 100, then 160, then 185, and then 200. So adding these with a calculator gives us 775, which is less than 915. So we've got to work out the percentage by which they have overpaid, and this is in comparison to last year. So the cost was 915, and that is higher than 775. So we're going to go 915, take away 775. So it's £140 overpaid 140 out of 775, so that's the original amount, gives us 0.18064 and so on. So this is as a decimal. As a percentage, this is going to be multiplied by 100, so we get 18.06. Or simply 18%. This is Ellie's electricity bill for the first quarter of this year. Total electricity used £211.90. Dual fuel discount, that is £14.90 taken off, and VAT £9.85. Total including VAT £206.85. VAT is calculated after discount. What percentage has been used to calculate the VAT? As the discount is done first, we're going to do 211.90, take away 14.90, gives us 197. So the VAT paid is £9.85 out of the £197. So we'll do that in the calculator. 9.85 divided by 197 gives us 0.05, which is 5%. X-Power for a loyalty plan. The formula X-Power used to work out the cost for the loyalty plan is D times 365, all in brackets, add in brackets P times G, where D is daily charge in pounds, P is price per kilowatt in pounds, G is gas used per year in kilowatt per hour. For this plan, the charges are daily charge 32 pence, price per kilowatt per hour 3.10 pence. Last year, Ellie's family used 17,563 kilowatts per hour of gas. This costs £719.38. Should Ellie's family choose the loyalty plan for their gas? Show your working. So we're given the daily charge, which is 32 pence, so that is going to be 0.32 pounds, and price per kilowatt is 3.10 pence, so we're going to write this as 0.031. And in terms of gas used, we've got the number of kilowatt per hour units in there. So now D is 0.32 multiplied by 365, all in brackets, add P, which is 0.031, multiplied by G, which is 17563. So 0.32 times 365 gives us 116.8, and add to that 0.31 times 17,563, which is 544.453. Adding them together gives us 661.253. Let's compare it to the amount that they pay, which is £719.38, so it works out cheaper. So should Ellie's family choose the loyalty plan for their gas? Yes. The average UK gas bill is 3.875 times more than the average UK electricity bill. Write 3.875 as an improper fraction. So this is 3,875 out of 1,000. So it might help to think of it in terms of grams in a kilogram. So if you have 3,875 grams, it's going to be 3.875 kilograms. And that is out of 1,000 grams. Write 3.875 as a percentage. So as a percentage, this is, as we can see, is greater than 100%, is greater than 1. So that is 387.5%. Ellie looks for information on the cost of leaving gadgets on standby when they are not being used. Ellie's gadgets are a TV, computer, printer, phone charger, and 2 game consoles. He finds several reports stating how much electricity Gadget uses when left on standby, but they do not agree. Use an estimate of the mean to find out how much money Ellie could save if he switched off his gadgets instead of leaving them on standby. So we're going to estimate the mean using a midpoint. So between 0 and 4.99, we'd have 2.50 and then multiplied by 1. And then the midpoint between 5 and 9.99 is going to be 7.50 multiplied then by 4. Between 10 and 14.99, the midpoint will be 12.50. Midpoint between 15 and 19.99 is going to be 17.50. Working these out, 2.50 times 1 gives us 2.50. 7.50 times 4 gives us 30. 12.50 times 5 gives us 62.5. 17.50 times 2 gives us 35. Adding all of these together gives us 130. And now we're going to divide it by how many there are. So we've got 1 and 4, which is 5, and the 5, 10, and the 2, 12. So we're going to do 130 divided by 12 gives us 10.833. So 3 is recurring. And in terms of money, that would be £10.83. So £10.83 for one device. But there are 1, 2, 3, 4, 6 of them. So we're going to go 6 times 10.83, which gives us £64.98.
And this is the end of the paper.